2. So we're going to push this door using the force of 20 newtons, and the lever arm is going to be 1.5. So to get the torque, we multiply the force by the lever arm, which is 20 multiplied by 1.5, and that will equal 30 newton meters.
Hey guys, Wyatt here with another torque question for you. So you're heading into physics class and you push on the door into physics with 15 newtons of force at a 30-degree angle from the very edge of the door, which is going to be 1.5 meters away. That'll be your lever arm length. Now another student at the same time is going to be pushing with 17 newtons of force at a 15-degree angle, but only 0.8 meters away from the hinge, or the axis of rotation in our case. Since torque is force times lever arm times sine of the angle of your force, and lever arm is the distance from the force to the axis of rotation, we can figure out which student is going to be able to pass through the door. So the sum of all the torque in the system is going to be your torque minus the other student's torque, since counterclockwise in this system is going to be positive because you want to enter the door to get into the classroom. Your torque is going to be 15 newtons times 1.5 meters for your lever arm times sine of 30 degrees. So your torque is going to be 11.25 newtons meters. Now the other student is going to be 17 newtons times 0.8 meters times sine of 15 degrees for their angle. So their total torque is going to be negative 3.52 newtons meters. Now their answer is negative because they're pushing the opposite direction of you, so they're trying to get out the door. So the total torque in the system is going to be your number minus the other students, which would give you a total torque of 7.73 newton meters in the system. So you will be able to push the door harder than they will, allowing you to get into physics class.
Hi guys, my name's Kennedy and I'm going to be teaching you how to find the cross product between two vectors. So let's say you have two vectors, vector A, which I'm writing in blue here, and vector B, which I'm writing here in red. To find the cross product between vector A and vector B, we're going to have to use the equation for cross product, which is A times B times sine of phi times the direction, where A is going to be the magnitude of A, B the magnitude of B, and phi the angle between the two vectors. To find the direction, we're going to have to use something called the right-hand rule. The direction of the cross product must be perpendicular to the plane that vectors A and B are already in, and it must be either towards the screen or away from the screen, because those are the only two directions in the plane perpendicular to the two vectors. To use the right-hand rule, take your right hand and place it on vector A and curl your fingers up towards vector B. You see that you have to use your hand this way and not this way, because if you curl your fingers this way, you won't reach vector B. Place your hand this way, curl your fingers up, and your thumb will be pointing away from the screen. This means that the direction of the cross product is away from the screen. Putting it all together, the cross product is A times B times sine of phi times the direction away from the screen, where A is the magnitude of vector A, B is the magnitude of vector B, phi is the angle between the two vectors, and away from the screen is the direction.